Hello and welcome to this video where we'll be diving into the world of domain-driven design. If you're a software developer or architect, you've likely heard about domain-driven design, but may be wondering what it's all about and how it can benefit your projects. In this video, we'll explore the key concepts of domain-driven design, its benefits, and how to apply it in practice. By the end of this video, you'll have a solid understanding of domain-driven design and be equipped with the knowledge to implement it in your own projects. So, let's get started. Domain-driven design, DDD, is a software development pattern that focuses on understanding the business domain and aligning the software design with it. DDD emphasizes collaboration between technical and non-technical team members to develop a shared understanding of the problem domain. By prioritizing the business domain, DDD aims to produce software that is more maintainable, extensible, and aligned with business needs. Understanding the business domain to create software that solves business problems, developers need a deep understanding of the domain they are working in. Understanding the domain means being familiar with the business processes, stakeholders, and goals of the organization. This understanding enables developers to identify the important concepts, relationships, and constraints of the domain, which can be modeled in the software. Ubiquitous language. Ubiquitous language is a language that is shared by all team members, including business stakeholders, developers, and testers. It is a way to establish a common vocabulary and understanding of the problem domain. The goal of a ubiquitous language is to reduce misunderstandings and improve communication. Developers should use the same terms as the business stakeholders, and vice versa, to avoid confusion and ensure alignment. For example, suppose a company is developing an e-commerce platform. The business stakeholders may use terms like shopping cart and order confirmation, while developers may use terms like cart and checkout. To establish a ubiquitous language, both groups should agree on a common set of terms to describe these concepts. Bounded context. A bounded context is a boundary that defines the scope of a domain model. Bounded contexts help to break down complex domains into smaller, more manageable parts. Each bounded context should have a well-defined responsibility and a clear interface with other bounded contexts. For example, in an e-commerce platform, the ordering system may be a bounded context that is responsible for managing the order process. The inventory management system may be another bounded context that is responsible for managing the availability of products. These two bounded contexts may interact with each other through well-defined interfaces, such as APIs. Building blocks of domain model. The building blocks of a domain model are entities, value objects, aggregates, repositories, and services. Each building block represents a key concept in the domain. Aggregates. An aggregate is a cluster of related objects that are treated as a single unit. Aggregates are used to ensure consistency and integrity within the domain model. An aggregate has a root entity that acts as the gateway to access and modify the objects within the aggregate. Changes to the objects within an aggregate are made through the aggregate root. For example, in an e-commerce platform, a shopping cart may be an aggregate. The shopping cart may contain multiple line items, each of which represents a product that has been added to the cart. The shopping cart may also have a total price, which is calculated based on the line items. Entities. An entity is an object that has a unique identity and life cycle. Entities are used to represent concepts that have a persistent identity, such as customers, orders, and products. Entities are distinguished from value objects by their identity, which is independent of their attributes. For example, in an e-commerce platform, a customer may be an entity. Each customer has a unique identifier, such as an email address, and a set of attributes, such as a name and address. Value objects. A value object is an object that has no unique identity and is defined solely by its attributes. Value objects are used to represent concepts that have no persistent identity, such as dates, times, and addresses. Value objects are distinguished from entities by their lack of identity. For example, in an e-commerce platform, a product may be a value object. Each product is defined by a set of attributes, such as a name, description, price, and weight. However, products do not have a unique identity that persists over time. Repositories. A repository is a mechanism for storing and retrieving domain objects. Repositories provide an abstraction layer that separates the domain model from the persistence mechanism. This abstraction enables the domain model to remain decoupled from the details of how the data is stored and retrieved. For example, in an e-commerce platform, a product repository may be used to store and retrieve products. The repository may provide methods for adding, deleting, and querying products. The implementation details of how the products are stored and retrieved, such as in a database or a file system, are hidden from the domain model. Domain services. A domain service is a mechanism for encapsulating domain logic that does not naturally belong to a particular entity or value object. Domain services are used to model operations or processes that involve multiple entities or value objects. For example, in an e-commerce platform, a checkout service may be used to handle the process of completing an order. The checkout service may involve multiple entities, such as a customer, a shopping cart, and a payment method. The logic for calculating taxes, applying discounts, and processing payments may be encapsulated in the checkout service. Implementing domain-driven design. To implement DDD, developers should start by gaining a deep understanding of the business domain. They should work closely with business stakeholders to identify the important concepts, relationships, and constraints of the domain. Once the domain has been modeled, developers can use the building blocks of the domain model, such as entities, value objects, aggregates, repositories, and services, to implement the software. DDD emphasizes a collaborative approach to software development, with communication and feedback between technical and non-technical team members being essential. DDD also emphasizes the importance of testing and validation to ensure that the software is aligned with the business domain. Conclusion. DDD is a powerful software development pattern that emphasizes the importance of understanding the business domain. By focusing on the domain, developers can create software that is more maintainable, extensible, and aligned with business needs. The building blocks of the domain model, such as entities, value objects, aggregates, repositories, and services, provide a powerful toolkit for modeling complex domains. DDD requires collaboration between technical and non-technical team members, as well as a focus on testing and validation, to ensure that the software is aligned with the business domain. Thanks for tuning into this video. If you found this content valuable, please give it a thumbs up and share it with your friends and colleagues. And if you haven't already, be sure to subscribe to our channel for more great content like this. By hitting that subscribe button, you'll never miss out on the latest insights, tips, and strategies that we share. So, don't forget to like, share, and subscribe, and we'll see you in the next video.